taking a look at rectangles. So we're going to look at what properties make a parallelogram a rectangle. So rectangle has all of the same properties as a parallelogram, but it has these two additional properties right in here. The first one is that diagonals are congruent to one another, and then the other one is all of the angles are right angles. Now that one you're probably super familiar with, but all angles are right angles, which means they're all 90-degree angles. All of those sides are perpendicular to one another. So let's take a look at these diagrams, kind of look at some of these properties and try a couple examples real quick. First one I want to take a look at here is the diagonal property. So in a rectangle, the diagonals are congruent. Now, this diagram is showing that the pieces of the diagonals are all congruent to each other, but it is also important for you guys to know that this full line here, this diagonal, is congruent to the other diagonal in that rectangle. Now, a quick example of this, it says in rectangle ABCD, we don't have a picture. So that's going to be our first sign to say, okay, let's draw a quick picture of this rectangle. So we have rectangle ABCD, so A, B, C, and D. And they tell us that AC, this diagonal right here, is Z plus 40. Then they also tell us that BD, this diagonal right here, is 4Z minus 11. Now, the property that we're interested in is that diagonals are congruent. So we know Z plus 40 is equal to 4Z minus 11. And we could go ahead and solve for Z. So I'm going to subtract Z from both sides. When we do that, we end up with 40 equals 3Z minus 11. I'm going to add the 11 to both sides. I end up with 51 is equal to 3Z. And as I solve for the Z, I'm dividing by 3. We end up with Z is equal to 17. Now, we want to find the measure of each diagonal, right? That's actually not our final answer. For our final answer, we're going to have to find AC, which since we know that's Z plus 40, I'm going to substitute that 17 in for Z plus 40. And we end up with a 57 degree, not 57 degrees, but a length of this line that's 57 units long. And then we also know diagonals are congruent. So if I do 4 times 17 minus 11, I should also get 4 times 17 minus 11, 57, right? 57 units long for those two diagonals. All right, now our other property that we're taking a look at today for the rectangles is that all angles are right angles, which means all angles are 90 degrees. That's, again, probably the most well-known property of that rectangle. Now, in the rectangle below, we have ABCD. We know that angle 1 is 2x minus 12, and angle 2 is 3x plus 2. Our goal is to find the measure of each of these two angles. Now, the important thing for us is to know what is the relationship between these two angles. We know angle A is a right angle, which means those two angles should add up to 90 degrees, being that right angle. So we're going to take our 2x minus 12, we're going to add our 3x plus 2, we're going to set this equal to 90 degrees. So when angles add up to 90, it also means that they're complementary angles, right? So two angles that add up to 90 are complementary. So 2x, we'll combine some like terms here. I have the 2x and the 3x, we get 5x, negative 12 and positive 2, we're going to get minus 10 here. That equals 90. I'm going to add the 10 over to the other side to help solve. We end up with 5x is equal to 100. And I divide both sides by 5. I'm going to end up with x equals 20 degrees. Now, they want to know the measurement of each angle, so I'm going to just substitute in here to find measure of angle 1. I'm going to take 2 times 20 and subtract 12, which is 40 minus 12, which we end up with 28 degrees. So angle 1 is 28 degrees. And then finally, we'll find angle 2. The measure of angle 2 is equal to 3 times 20 plus 2, which is 60 plus 2, or 62 degrees. And a nice way for you to check these answers is to make sure that 28 plus 62 equals 90, and we're good to go. So try a couple of the problems on the back. Let me know how it goes, and we'll continue on today.